Hey Eli, you know what day it is?
No.
It's Saturday! Let's learn about gas laws.
Fuck gas laws and fuck Saturdays. I hate fucking weekends. Because I've never had fucking anything to do. Fuck you.
Well, in order to learn about the gas laws, we first have to know about the kinetic theory.
I hate you.
It's cool!
Learn me some shit. Go ahead.
Alright, the kinetic theory. Gas particles do not attract or repel each other. They are much smaller than the distance between them and have virtually no volume. Gas particles are in constant random motion. Their collisions are elastic. No kinetic energy is lost. All gases have the same average kinetic energy at a given temperature. You know, one of the laws is Boyle's law, and it explains that when volume goes up, pressure goes down, and when pressure goes down, volume goes up. So they're inversely related.
That's enthralling. I've never heard anything more fascinating in my entire life. Ever. Thank you for that information. Please.
This is good shit, okay?
I understand it's good shit. That is why I'm learning it. I know about Boyle's theory now.
Formula for Boyle's law is the initial pressure times the initial volume equals the final pressure times the final volume. Or the formula for our next example will be the final pressure times the final pressure is equal to the initial pressure times the initial volume divided by the final volume. A sample of helium gas is compressed from 4.0 liters to 2.5 liters at a constant temperature. If the pressure of the gas in the 4.0 liter volume is 210 kilopascals, what will the pressure be at 2.5 liters?
I don't know. Please describe the answer to me.
The initial volume is 4.0 liters, and the final volume is 2.5 liters. The initial pressure is 210 kilopascals, and we're trying to find the final pressure. Since in this equation, volume is going up, volume is going down, pressure will go up. So you multiply 210 kilopascals by the division of 2.0 liters by 2.5 liters, and the answer is 340 kilopascals.
Wow. I feel that I've learned so much about, what was it? Boyle's law. Yes. I now know the meaning of pressure and life and love and death. Please tell me more.
Remember that Boyle's law is dealing with pressure and volume, so in its equation, temperature must remain constant.
Oh, cool.
There's another law too, Charles' law, but Charles' law deals with temperature and volume. Unlike Boyle's law, temperature and volume are directly related, or directly proportional. So when temperature goes up, volume goes up, and when temperature goes down, volume goes down.
I never knew that before. Thank you so much for telling me. Continue.
Okay.
Continue!
I don't know what. Okay. The formula for Charles' law is initial volume divided by initial temperature is equal to final volume divided by final temperature. Or, for our example, the final volume equals the initial volume times the final temperature divided by the initial temperature. 30.0 degrees Celsius occupies a volume of 2.32 liters. If the temperature is raised to 75.0 degrees Celsius, what will the volume be, assuming that pressure remains constant? The initial temperature is 40 degrees Celsius. You add 273 to this to get 313 Kelvin. The final temperature is 75 degrees Celsius, or 348 Kelvin. The initial volume is 2.32 liters, and the final volume is what we're trying to find. Since in this equation, the temperature is going up, the volume will also go up. The final volume is equal to 2.32 liters times 348 Kelvin divided by 313 Kelvin. The answer is 2.58 liters. Remember, in Charles' law, it deals with volume and temperature, so pressure stays constant.
That's amazing.
Our final law is Gay-Lussac's law, which
Continue.
which deals with pressure and temperature. When Pressure goes up, temperature goes up. And when pressure goes down, temperature goes down. Pressure and temperature are directly proportional.
According to Gay-Lussac.
Formula for Gay-Lussac's law is initial pressure divided by initial temperature is equal to final pressure divided by final temperature. Or, for our next example, we'll manipulate this, so final pressure is equal to initial pressure times final temperature divided by initial temperature. The pressure of a gas in a tank is 3.20 atmospheres. At 22.0 degrees Celsius, if the temperature raises to 60.0 degrees Celsius, what will be the gas pressure in the tank? The initial temperature is 22.0 degrees Celsius. When you add 273, it becomes 295 Kelvin. The final temperature is 60.0 degrees Celsius, or 333 Kelvin. The initial pressure is 3.20 atmospheres, and the final pressure is what we're trying to find. Since in this equation, temperature is going up, pressure will also go up. So the final pressure equals 3.20 atmospheres times 333 Kelvin divided by 295 Kelvin, which equals 3.61 atmospheres. Remember, Gay-Lussac's law deals with pressure and temperature, so volume remains constant.
Gee, that is enthralling. I am so glad to know all this about Gay-Lussac's law.